Thanks, Aaron, for that awesome presentation. Next, we'll have Taylor Whitman from Tata Consultancy Services.
Can you hear me? Okay, there we go, cool. I know what you are all thinking right now. Who is Tata Consultancy Services? What is TCS? Hands up if you have ever seen our logo before. That is highly impressive. Well, we've only had a few people raise their hands, but it's interesting because Tata has been in Australia for over 30 years. Last year we had over $25 billion of revenue come through. We have over 500,000 employees across 46 countries, yet only a very small portion of us have seen our logo before. There is a reason for that. Tata Consultancy Services is primarily an IT organization and consultancy, which means that a large portion of people who work at TCS are consultants, and a large portion of people also work in tech. And so what do we consult on? Well, we have a set of clients who come to us and say, hey, we have a problem, we want to improve our business, what technical solution can you provide to solve our problems? And so our consultants will go between those clients and our technical teams to digitally empower with technical solutions. So you might not recognize TCS, but you might recognize a few of our clients. Hands up if you've seen our clients' logos before. Everyone in the room. So our job at TCS is to go between these guys and a whole lot more and provide them with technology to improve their business. So my name is Taylor, I work at TCS, and today I want to share with you a methodology that we use to problem solve, a methodology that our consultants use, our technical teams use, and even our executives use. It's called computational thinking. So for the next 15 minutes or so, I want to ignite your future by sharing with you the methodology of computational thinking. It was proposed in 2006 by Jeanette Wing, and at TCS, we believe that if you employ the strategies of computational thinking, you are going to be able to problem solve with accuracy, you're going to be able to problem solve with logic, and you're going to form innovative solutions to your problems every single time. So there are 7 strategies to it. I'm going to walk you through them now. So the first one, you're doing this all the time, you're doing it right now, it's collecting data. So taking information from somewhere and storing it, constantly doing it. And the next one, analyzing that data. When you comb through all that data and you start to process it and you apply statistics and other things. If you guys have ever weighed up your marks at school, if you've found out your percentage rank by adding all your marks and dividing them, or even if you've asked your friends about what their ranks were so you could scale yourself in the class, then you have used the computational thinking strategies of collecting and analyzing data. You can solve problems of things like, will I pass? Or what uni will I get into? Or how much effort do I need to put into this assignment to not fail? The next one I'll talk about is abstraction. So abstraction is where you take a really big problem and you remove all the extra details and you make it more simple. So it's like when your English teacher asks you to find the theme of a novel. And you take away all the extra sentences, all the extra words, and you bring it down into that one main theme. That is abstracting, making something more simple. So hands up if you've ever seen a weather report. Or if you've ever looked at the weather radar. Okay, cool. So the weather radar and the weather report are really good examples of building models. So building visual models out of data. So when we look at the weather report, when we see those big rain symbols sweeping across maps or colored lines sweeping across maps as well, that is an example of the computational thinking strategy of building models. So the weather report allows people like us who maybe wouldn't understand the raw data of weather to solve the problem of, is it going to stop raining tomorrow? Or when will it next be sunny? Or can I go camping this weekend and actually enjoy it? Now, the next one I don't want you to shy away from, because developing algorithms is simply creating a set of instructions. An algorithm is just a set of instructions that leads to an endpoint. So if you have ever made a major work, so when your DT teacher, your food tech teacher, or if your woodwork teacher asks you to make a major work and you have to take down every single thing that you did to get to that major work, you take down every single step. That is developing an algorithm. So when you take down the steps that you took to make that piece of furniture, or that piece of clothing, or the recipe, you have developed an algorithm. Now, speaking of instructions, I want you to think back to the last time you wrote an essay. Do you guys remember writing the introduction and the body and the conclusion? So writing essays is a really good example of decomposing problems. Now, decomposing problems is when you take a big problem and you break it down into smaller, more manageable pieces. It's why when we write an essay, we break it down, because it's easier to tackle a really large task if we make it into smaller, more manageable chunks. So when we write our essay in sections, what we can do is take that, that seemingly impossible task of writing a 3,000-word answer into something that's a little bit easier, a little bit more manageable. The last one I'll show you is finding patterns. Now, finding patterns is simply seeing similarities between different problems. It's like when your art teacher asks you to find similarities between different works of art. And you look for similar colors or similar shapes, or you look for similar brushstrokes or similar pigments. You are finding similarities. When we employ the computational thinking strategy of finding similarities, what we can do is we can find a solution that can better fit a range of problems instead of just one. So those are the 7 strategies. You've done them all before. You're probably doing them constantly. We're just giving them a name now. We're just giving them a name. So how can you use these in real life? What do these have to do with careers? Well, hands up, can anyone tell me what they see here? Yeah, just up here in the front. An emoji, interesting. Okay, does anyone have a different answer to that? Over on the side? A person thinking, okay. All right, so we've got an emoji, a person thinking. Any different answers? Right up the back, big loud voice.
A black sheep.
I didn't quite catch that.
Someone looking at something and thinking this is interesting.
Okay, someone looking and thinking this is interesting. Okay. And one last one up on the side. A visual representation of confusion. Okay, so we've got a few different answers of emoji or a person thinking, a visual representation of confusion. All in all, we can probably see a face. We can probably see a raised eyebrow, frowning mouth, maybe a pointing hand. If we break it down even more than that, we might see a yellow circle, some smaller brown circles, a few different brown lines. But how many of you guys thought of that first? Or did you all just go to the thinking or the emoji, or maybe you went straight to the actual feeling of, I don't know. What about this one? Does anyone want to take a guess at what this one says over here? You woke up late, so you run to school. Okay, interesting. That's very nice. Does anyone have a different answer? Over here? Okay, we've had the answer of a clock, a sleeping face, a girl running, and a school. You guys are both correct. In general, I slept in, so I had to run to school is the message that's being conveyed up there. So emoji is a really, really good example of computational thinking. Does anyone want to take a stab at which of the computational thinking strategies you are using when you interpret emoji? Yeah, up the front. Building models, because it's visual representation, absolutely. What about over here on the side? Abstraction, okay, absolutely. What else do we have? Let's go, yeah, we'll go to you. A bit of decomposing problems, I agree. Yeah, over here. Analyzing data, absolutely spot on. Right up the back. Collecting data, yes, okay, and one more. Sorry, what was that? Finding patterns, yes. Okay, you guys are excellent. So emoji is a really good example of a lot of the different strategies in computational thinking. Like I said before, you guys have all used the strategies of computational thinking before. You just probably haven't realized it. We're just giving them a name now. So emoji, you're absolutely right, is an example of abstraction. Because when we represent emoji, we're representing an emotion. And we've made that emotion really, really simple, and we've put it into just one simple picture. And so when we saw that thinking emoji first up, most of us just went straight to the emotion and we felt the emotion. Emoji is also an example of how we can build models. So when we put the different emojis together, we can start to build visual models of scenarios like sleeping in and running to school. And finally, emoji is also an example of how we can decompose problems. So when you saw that string of emojis before, of I slept in, I had to run to school, did you read them one by one? Did you read them all together? Or did you take them in blocks? Did you maybe read 1 and 2 together and then 3 and 4? So when we see long lines of emojis, often our brain automatically decomposes the problem and breaks it down so we can ascertain the meaning. But what does emoji have to do with jobs and careers and anything in the real world? Well, we know that emoji is constantly being used by people in real world careers, real world jobs to solve their problems. So because emojis harness our emotions, we know that graphic designers love to use them in their work because it makes us more likely to participate in their logos if they have faces in them. And the same as marketing professionals. When we're given a survey after our experience at a shop or a restaurant or anything like that, often they'll try and have you answer based on an emoji. It makes you more likely to do the survey. Now we also know that medical professionals have used emojis. So you can see up there the Wong pain assessment tool. So this was a scale created by medical professionals to help children express how much pain they were experiencing. Because I don't know if you guys have ever seen a child in pain, but it's extremely difficult to get any meaningful words out of a child in pain, okay? They're usually just screaming or crying. But what doctors noticed is you can't ask the child how much pain they're in. You can't ask the child to scale their pain, but you can ask them to point to which one they feel. So emoji is an example of computational thinking that is used across a whole bunch of different careers, not just in tech. So if computational thinking is something that you already do it in emoji, you already just do it in school, you're already employing the strategies, then why bother? Like why would I bother standing up here talking to you about it? And well, the answer to that is because one day you're going to face a problem that is simply too hard to solve. You're going to have a problem that you don't know where to start. And it's going to make you want to scream and run and cry. You might have already had one of those problems in school where you looked at it and you were like, just not today. So I want to give you an example of something we had at TCS. So I said before, at TCS, it's our job to solve our clients' problems with technology. So I want to give you an example of what kind of problems we come to face with sometimes. So how would you solve the problem of saving rhinos from being poached with technology? I'll show you what we did at TCS. So without computational thinking at TCS, we simply would not have been able to solve the problem of rhinos being poached with technology. And moreover, without computational thinking, we would never have even been able to work in an area like poaching or conservation. My clicker's stopped working, if anyone can change for me. I will just keep going. So with the rhinos being poached, we saw that those drones were fully autonomous. And what that means is there was a bunch of computational thinking of collecting data and analyzing data that was involved in that. So we had to have all our technical teams running through all the different data sets so those drones could fly across those big, wide distances. So we had all the computational thinking strategies of collecting data, analyzing the data, finding patterns, and also developing algorithms. Our tech teams were amazing with flying those drones and getting those drones to build all those data stores. But also on the other side of that, I want to highlight that there's a bunch of non-technical teams that are constantly employing computational thinking. So our consultants, which I spoke about before, whose job it is to go between the tech team and the client. So they're constantly decomposing really, really big problems and abstracting information so they can represent technical information to our client. On top of that, our sales team, they're the ones going out and identifying patterns in different sales targets areas. So they're the ones being like, oh, we can go out and work in an area like conservation. We also have our project managers who are decomposing problems to make sure that every person in the team has a finite and achievable task. And finally, our marketing team, who are creating amazing videos like this and showing the world what we do here at Tata. They're also building models and analyzing data all the time. So you can see that computational thinking isn't just in tech. Thinking like a computer scientist isn't just in a technical role. It's also across an entire organization. So thank you so much, guys. It's been an absolute honor. Does anyone have any questions? Yes.
Earlier when you're showing companies that your company works for, you brought up Westpac. Earlier on, the previous person who was on talked about how his company worked with Westpac. Has your company and his company ever worked together?
Not that I know of. But then, you know, it's a big world. I might not know everything. Yeah. We did. Amazing. Well, there. We have worked together.
In Tata Consultancy, do you guys directly work with technological aspects of the problems and stuff?
Yes. So at TCS, we have technical teams. So we build our own software and we also deploy other companies' softwares as well. So we work directly with the technology. Yeah. Over on the side?
In the video, you showed drones protecting the rhinos. Did the drones fly themselves, or do people pilot them?
The drones were autonomous, yep. So there were algorithms that were driving the drones. Just here?
Is it just called computational thinking, or are there other names or other acronyms?
Well, can you repeat that one for me, sorry?
Is it just called computational thinking, or other names or acronyms?
So computational thinking it was proposed by Jeanette Wing in 2006 because she brought all those different strategies together and put them under one paper. But these things have existed before that. So you might see the same things like abstraction or decomposition, those ideas, those big ideas, falling under different titles or headings. But yeah, when you put them all together, we call it computational thinking because you're thinking like a computer. Yeah.
Yeah, so in the
that video, it says like the drones are like always operating. So like, as far as I'm aware, I'm actually a resident from India, right? So as far as I'm aware, there are quite some villages and like people that are still ground patrols that are working with the drones. How do we know that they're actually pinpointing the poachers rather than actually someone who's actually still living there?
Okay.
Yeah.
So how do we know the drones are doing what they're supposed to be doing?
Yeah.
Okay. So when that video was made, drone technology was something that TCS was specializing in. We're pouring a lot of money and a lot of time and a lot of resources into building these kind of technical solutions, especially in drones. So that research that you would have seen there would have been very carefully monitored, because it would have gone into basically our business for that year, because we were pouring so much time and effort into it. I'm sure that sometimes the drones did what they weren't supposed to do, but that's part of business. We identify what's going wrong and we always try and improve it. I think I'll take one more from up the front.
What was the time frame of being presented with the Rhino problem and then coming out with the drone solution?
That is an excellent question, and I don't know. So in a business like TCS, sometimes your client will present you with a problem, say on January 1st, and December 1st, it's still not solved. But sometimes they'll present you with a problem on January 1st, and then January 1st in the afternoon, you'll say, we can fix that right away. So it depends on the problem, it depends how much novel thinking has to go behind it to solve it, and it depends on the client and the team and how effective you're working together. For that particular example, I actually don't know the timeline. But yeah. Do we have time for one more? Are we okay? Okay, yeah.
So where do you fall on like that, the little thing up there? Would you be like marketing team or sales team or?
Where do I fall up there? I'm actually not up there.
Oh, okay.
Haven't included myself with that one. I didn't work on the Rhino project.
Yeah,
but,
okay.
I guess I would fall under another box, which is I personally work in corporate social responsibility and STEM programming. So this is my job. So I would be in a separate box to those guys. Guys, I have a booth outside. If you have any more questions, I'd love to answer them. Thank you so much and have a fantastic day.